Let's get going. Right. Okay, so the webinar today is looking at sealed spherical roller bearings in the SKF range. Within the webinar, we hope to provide knowledge about the product range and its features, identify the benefits of sealed spherical roller bearings in optimizing your service life, improving your maintenance intervals and reducing your grease consumption. Look at how we can optimize the benefits of sealed spherical roller bearings using the SKF 3 barrier solution, and look at some case studies to show how it's used in practice. Okay, so why a sealed spherical roller bearing? Sealed spherical roller bearings are used in extremely demanding applications generally. Generally in a housing, very close to ingress of contaminants. In fact, when we review the bearing environment spherical roller bearings are used in, only 25% of typical environments are classed as clean. So most of them will produce contaminants which could get into the bearing, reducing service life. In reality, what do we see in the field? We see numerous applications where there is either high temperature, lots of water, lots of dust, lots of combinations of water and dust, grease from other parts of the application going around the bearing housings. All of this could get into your bearings and reduce your service life. So, looking at the product range and features. Sealed spherical roller bearings are built on the upgraded SKF Explorer bearing for spherical roller bearings. This gives you already a significant upgrade on previous spherical roller bearings, even compared to the original SKF Explorer. In testing, we've seen an improvement in the wear resistance of the material, and this has been brought about by a specific heat treatment, which has increased the wear resistance. And basically, under poor lubricating conditions, we generally see up to twice the service life. And if we have severe contamination, we can see again up to twice the bearing life in service. So already you've got the benefit within the sealed unit of having an upgraded bearing which has improved wear resistance. Sealed spherical roller bearings, just to give you a quick overview of how they're made and what the range consists of. They're factory filled with a high performance grease. They are available in both tapered and cylindrical bore. They have the same load carrying capacity as the open versions. Currently they're at the same availability as the open spherical roller bearings. They have a slightly reduced misalignment capability due to the seals, but at 0.5 of a degree, this is generally enough for most applications. And there's a very large assortment within the ISO dimension range. So in terms of sealing, there's two types of sealing material available. There's NBR and there's HNBR. They can see that they're available with different suffixes which tell you which material it is, and the material is dependent on the dimension series and the size of the bearing. In terms of lubricants, the standard fill is what we use in the suffix of VT143, which is the same as SKF LG EP2, so it's an EP2 grease. Optional fills for more specific applications are GEM9, which is LG HP2, a calcium sulfonate grease, and LG WM2, which is again a specific grease for varying operating conditions. In terms of the range, we've got an expanded range currently available up to a bore of 420 millimeters. SKF offers the widest range of sealed spherical roller bearings on the market. We have a large range up to, as I said, between 25 and 400 as standard, and we increased to 420 currently. What it's worth noting at this point is some bearings in the 222 and 223 series have to be slightly wider to accommodate the seals. This means the width doesn't meet the ISO definition of a 222 or a 223 series. So when we're designing with this type of bearing, we have to take that into account in terms of the housing bore and any sealing arrangements external to the bearings. Additionally, and a recent addition to the SKF portfolio was the SKF Cooper split spherical roller bearing. These are available in the open and a sealed version now. Dimensions are in the standard series from a bore size of 240 millimeters up to 450 millimeters. We can produce other dimensions on request. And you will see the way the designations are set up is you have the same bearing, core bearing designation for the bearing as an open. And if we're making a sealed version, then we have a -2 SRS on the end of it. And you can see a picture here of an opened up sealed spherical roller bearing from the Cooper range. So the benefits of using sealed spherical roller bearings. They are seen to be better for the environment. We have less chance of waste in terms of grease consumption. We have less maintenance required, especially if you're in hard to reach places where they are effectively classed as grease for life. So you don't need to relubricate the bearing. They can be fitted and then they can be accessed at a convenient and safe time to carry out maintenance. And they're reliable. We have an extended mean time between failures due to the fact that they're sealed and you don't need to maintain them or interact with them until you hit a safe interaction point. But also in terms of the design, they're a simpler design. They're a sealed unit. The grease is contained within them. They save space and give you the opportunity to downsize, and we'll go into that in a couple of slides. And also working safer. Simplified maintenance. As I said before, the regreasing regime is reduced. Also fitting. It's a single unit and it can be fitted directly without having to add seals or additional greasing whilst mounting. Just a quick overview of the effectiveness of the sealing on the bearings. As you can see, when we did some testing comparing to the closest equivalent competitor bearings, dust ingress was significantly reduced compared to our competitors. And also water ingress from a water spray test were effectively twice as effective. So from a sealed spherical bearing point of view, these bearings are very capable on their own without any external sealing of preventing ingress of dust and water. Additionally, because they're sealed for life, the seals have an additional effect of retaining the grease. And this is seen as a big benefit in terms of you're not introducing contaminants when you're mounting the bearings. So the grease is already included in the bearing. You're not opening the bearing up and having an open bearing in a contaminated environment where potentially you could have ingress before you've even got the bearing into operation. A recent addition to the product range is the RS seal. This is improved seal. It's a lower friction seal, and it has some significant advantages over the original CS seal. It has a lower frictional resistance, up to 20% lower. This results in lower operating temperatures, as you can see from the graph on the right, where we compare an RS seal to a standard CS seal. For different speeds, we can have up to a 20-degree temperature difference between the two equivalent seals on the same bearing. What this has allowed is one of the original limitations of a sealed spherical roller bearing was the limiting speed. This was determined by the friction of the seal. by being able to reduce that friction for certain sizes of bearing, we've been able to increase up to twice the speed limit of the bearing, which opens up more applications, and therefore more applications can be performed with little maintenance. So looking at what has been experienced in the field, we know we've seen 3 times the effective service life compared to an open bearing. We can show that we can get 1/100th of the grease consumption compared to an open bearing. And in terms of relubrication intervals, we only have 1/10 of the required relubrication intervals required. All of these add up to a significant improvement in terms of the maintenance and the cost to maintain the application. So how do we achieve the longer bearing life? So if we take, in this example, the same bearing with the same applied load, and all we're looking at is the effect of the sealed versus an open bearing. The only factor which changes when we look in the graph on the right, where we determine the ASKF factor, the life modification factor, is the contamination factor on the bottom axis. So the fatigue load, the equivalent dynamic load are the same for the 2 compared bearings. The effectiveness of the lubricant, the kappa value, is the same. Thank you. And all we're looking at in this is what is the effectiveness of the sealed bearing. So changing the contamination factor in line with the SKF guidelines. For a sealed bearing, the contamination value factor is seen to be between 0.8 and 1. In this case, we'll take the worst case, which is 0.8. For an open bearing with normal housing seals, it gives us a range of between 0.1 and 0.3. So in this case, we'll take 0.3. Okay, so in terms of life, the SKF rating life is given by L10, which is C over P to the factor 10 over 3, times the SKF rating life factor. If we take this across onto the graph on the right, we use the SKF Explorer x-axis, and for an open bearing, we have a factor of, on here, of 0.6, and for a sealed spherical, 1.2. If we assume they've got the same kappa value of 1, which is the lowest of the effective lubricant range we would specify, you can see the difference in the SKF life modification factor. So in this case, 1.5 for an open bearing and 4 for a sealed bearing. So if we look at those, we've got a factor of 4 times the same basic rating life versus 1.5 times the same basic rating life. So that gives us an improvement factor in terms of bearing life of 2.7. So already we're seeing an improvement in our projected service life of the bearings. In terms of relubrication intervals, when we look at relubrication intervals using the SKF method, for this same bearing, it was determined that the relubrication interval for the bearing was 30,000 hours. We then apply correction factors based on the environment it's operating in, plus the effective airflow through the seals. Okay, so for a sealed unit, we have relubrication interval of 30,000 hours times a low degree of contamination times a sealed unit times 1, which is our grease performance factor, which gives us a relubrication interval of 30,000 hours. If we apply the same to an open bearing, we see a reduction in the factor for the environment to 0.3. We see a labyrinth seal, which is typical of this application, of 0.3 times the grease performance factor of 1, which gives us 2,700 hours, which is about 10 times difference in relubrication intervals. So we would have to relubricate the open bearing 10 times before we needed to relubricate a sealed version. Now, one thing which is generally asked is, why do we have to relubricate a sealed bearing? Sometimes it is possible, and it's to do with if the rating life of the bearing is significantly high, we can relubricate the bearing to achieve the mechanical life of the bearing rather than just the grease life of the bearing. In terms of reducing the grease consumption, what we found in the field is when we have open bearings in housings, the general maintenance procedure is to push grease out of the seal, to purge the grease back out of the seal to remove contamination. So rather than the actual grease needed to secure the grease life of the bearing under the clean conditions, a factor of 5 is applied. There's 5 times as much grease put into the bearing housing than is actually required for the bearing to function. So as you can see in the images, we see large amounts of grease purging out and collecting around the housing, attracting dirt and contamination buildup. We see it dripping here down in terms of the support structure. These all have problems environmentally, and with some of the new guidelines and protocols being introduced by governments about waste control, this is problematic for a lot of applications. So if we compare an open bearing and a sealed bearing, we generally see longer intervals before we need to re-grease due to the protection provided by the sealing. The grease required is only used for the actual separating the metal surfaces during rotation. It's not used for protecting the bearing from contamination. So if we look at an open bearing, we have 10 times the number of relubrication intervals. We have 5 times the amount of grease. So the amount of grease used is approximately 50 times that of a sealed bearing. And that relates to a 98% reduction in grease consumption using a sealed bearing. That's a significant grease reduction. Other benefits of using a sealed bearing is we've got the potential to downsize in the design. We've got a compact bearing design due to the fact that we don't need external seals. So we don't need to have, if you look at the old design here, we don't need to have an external seal running on the shaft. We could just leave it open. As we've seen, the seals are very effective just on their own of reducing ingress of contamination. Because we see the improvement in the life modification factor, ASKF, because we're using a sealed bearing, for an equivalent load, we could reduce the size of the bearing, and in terms of the SKF rating life, we could achieve the same rating life because we see an improvement in the ASKF factor. Additionally, these bearings are much easier to handle during mounting. You don't have to pre-pack them with grease. You don't have to add additional seals. The method of mounting is basically a single unit mounted into the housing. So again, you can see in the new design, we can simplify not just the bearing housing, but the frame structure. We can also simplify the amount of machining required onto, in this case, the drum of the winch. So overall, we can effectively reduce the cost of designing a housing to take these bearings. Now, sealed spherical roller bearings are generally used in very aggressive environments. So what we generally recommend is we look to use the 3-barrier solution in conjunction with them to make sure you get the most effective sealing solution and the best performance out of your sealed spherical roller bearings. So the SKF's 3-barrier solution was developed in the field, and it's designed to handle extremely dusty and dirty conditions, very similar to those seen on conveyors in mining applications or in high pressure washdown situations. Now in the annotation you can see on the right, we use a labyrinth seal with a sealed spherical roller bearing, and in the cross section you can see we've used an extreme version of the 3-barrier solution where we've used taconite seals. Additionally, we can use standard lip seals or machined lip seals in the housings. So the first barrier is the external seal. This prevents 95% of dirt ingress. Then we fill the housing up with an additional grease. It could be environmentally friendly or a recommended grease for the area you're working in the site. That reduces the grease contamination getting through that further until potentially we don't see any contamination at the seal of the bearing, and then we definitely don't see any contamination actually entering the bearing. So you've got an external seal, a middle seal made of grease, and then we've got an integral seal being the third seal. So in this case, as I said, the first barrier is an external seal. Generally we use a labyrinth seal, but we can use both a taconite seal for extremely demanding conditions, or within the SKF range, we now have new TX machine seals, which can be used effectively to replace lip seals. The second barrier, as we said, is a consistency grease placed in the void of the housing. This grease isn't used to lubricate the bearing and could be used as an environmentally friendly grease, which if it's expelled through the seals, it has less environmental impact. And then finally, the integral seal is the third barrier, the one on the bearing, and that allows the grease in the bearing to be used to lubricate the bearing whilst it's rolling and carrying the load. We don't get any contamination within that bearing. Just a quick word on mounting. Because we have two different versions of sealed SRBs available, we have a cylindrical bearing bore and we have a tapered bearing bore. The one thing to just be aware of is in terms of mounting against the abutment face, we need to ensure we use the right locking mechanism so we don't interfere with the seal. So the standard KM and MB tab washer locking system is not used for sealed spherical roller bearings. The KMFE nut is useful if we're going onto a cylindrical shaft. It has a little step out on the nut, which means that the main part of the nut is stood away from the seals. If we're on adapter sleeves, if you order the correct adapter sleeve for the sealed spherical bearing, it will come with the correct nut and locking mechanism. Generally, it's a KMFE nut, or it might be a modified KM locking nut. In terms of mounting on cylindrical bore, 80 degrees is the maximum recommended temperature that you heat the bearing up to. This ensures that the lubricant isn't damaged or degraded during mounting. And for a tapered bore, we can use a tapered sleeve or a withdrawal sleeve, and we recommend using SKF mount to give you the correct drive up distance, because due to the seals, you cannot measure the internal clearance on mounting. So just having a quick look at some case studies. Most of the case studies which we have available are based around conveyor solutions, because these are the most aggressive solution applications where we apply sealed spherical roller bearings. So in this case, we had a Swedish sand and mineral processor. In terms of annual output, they did 35,000 tons of sand on these conveyors, which had 88 bearing positions. they found it necessary to remove and replace the bearings every 9 months and the housings every 18 months. That was a big undertaking for maintenance and planning. In terms of downtime, it wasn't that long, 2 hours to change a bearing or a housing, but if the bearing had failed, it could take up to 4 hours. The main problem the customer was having was controlling how to schedule part replacement, lost production, and scheduling in manpower. We did a trial with the customer to understand what the best solution was. So we compared the standard open bearing solution, which they had. We looked at an open bearing with a taconite seal, which is a recommended SKF solution. But we also looked at a sealed SKF roller bearing with a standard lip seal. Now, over the 24-month test period, the open bearings failed every 9 months, as had been reported. The sealed spherical bearing with the standard lip seal, that did not fail in the 24-month test period, but additionally, the open bearing with a taconite seal didn't fail in the 24-month test period. However, the SKF sealed solution offered the big advantages in terms of lower overall costs, as you can see up on the cost comparison. But additionally, they didn't have to relubricate the bearings, they didn't have to relubricate the taconite seals, and they were able to use environmentally friendly grease to fill the void, which got approval from the environmental agencies in Sweden. So, as you can see here, in terms of 88 bearing units over 24 months, they originally had a cost of just over 46,000 euros. The cost to apply the SKF sealed spherical roller bearing solution was 22,800 euros, which gave them a cost saving of just over 23,000 euros over the 24 months. So again, the SKF sealed spherical units, they may, on the purchasing side, seem more expensive up front, but in terms of the cost over the life of the bearing, you do see an improvement. In this case, you can see here the difference between 524 euros to 260 euros over 24 months for each position. Another case where we've used the 3-barrier solution and we've managed to increase the service life by 100%, again, is another Conveyor application in Germany for an open cast mine. They have 40 bearing positions on the head and tail pulleys and the bend rolls, and their chief challenge was they were having premature bearing failures due to the ingress of grit and contaminants off the conveyors. This resulted in them having to use large amounts of grease to basically purge the contamination back out of the housings, which under the grease disposal regulations and the German environmental regulations was very problematic and very costly. So the SKF solution, again, we applied SKF sealed spherical roller bearings. Previously, the bearings had lasted about 730 days, approximately 2 years. With the sealed solution, we were able to achieve a full 4 years. But additionally, we reduced the cost of the disposal of used grease. The amount of time the maintenance personnel had to go around re-greasing the bearings was reduced, and mounting time was reduced from 4 hours to 2 hours. So overall, the additional benefits were significant. Just to show that we also have cases where we use clean environments for sealed spherical roller bearings in terms of drive systems for elevators. For this one, the big issue was going to a direct drive system. Although they could get higher speeds and greater energy efficient and get a more compact arrangement, they also had no gearbox, so they had no gear oil. So the bearings would have to be lubricated and therefore would require regular relubrication, which in a lift shaft is very difficult. Also, any leakage of grease could jeopardize the safety feature, the brake performance, and that wasn't acceptable. So we performed trials with them in terms of 3 months of endurance and function testing. And as a result of that, the whole production line for the lift mechanisms was changed over to sealed spherical roller bearings. So in summary, what we can see is we see potentially 3 times service life, which means for on-site, you can survive to planned maintenance, increase your availability of your assets, eliminate your risk of your failure, and also lower your total cost of bearing purchase. Reduce the grease consumption. Again, minimize purchase costs, disposal costs, reduce your environmental footprint, and reduce less scrappage of grease. We don't need to relubricate as often, so we have reduced maintenance requirements. We can plan for interventions on a better basis. We remove the risk of injury to personnel, having to maybe access difficult to reach locations, and you can focus manpower on tasks which need more optimization. Also, no worries. So we can focus more on production, not on preventing failures, but actually increasing production. We increase the safe working place, and in terms of the brand value for your company, your product, it's generally increased. So the bottom line results, we improve the sustainability of the product, competitive advantage by reducing cost to produce, we reduce the total cost of ownership for the asset, and we increase the KPIs, the availability, the productivity, cost per ton, and the operational efficiency. So in terms of contact details, as your first contacts, we would suggest speaking to your local regional sales manager in the UK, which in this case are listed here and shown in the map. And then just to give you some future webinars which are coming up, we've got a set coming up through June and July. And at this point, I'll hand back over to Ringo.
Okay, thank you, Ian. Thank you very much for this very clear and interesting webinar presentation. We have quite a few questions in the chat box, and I will go through them one by one. I propose. The first one is, what should be the minimum gap between the cage protrusion and the seal? Are there any specific guidelines, especially for large size bearings?
Yes, there are some guidelines given. They are kept, the best way to access them is through skf.com for that particular bearing size, where you'll have the design for the dimensions for the abutments, and also it will give you the correct locking nuts, or it will give you the required step out for putting a spacer in against a standard locking device. So I'd recommend going to the skf.com for that information.
Okay. Second question, how do you inspect a sealed spherical roller bearing in operation, especially with regards to clearance checking? Same problem would be there during mounting, as you cannot do a clearance check.
Yes. Okay. In terms of bearings with tapered bores, then SKF mount, using the SKF drive-up method is the recommended method. This will give you the correct axial displacement up the tapered journal or the sleeve to ensure you get the right clearance reduction. In terms of clearance reduction for cylindrical bearings, again, if you use the SKF tools, the online tools, to check the recommendations for the tolerance on the shaft, that will ensure you get the correct mounted clearance of the sealed bearing.
Okay, thank you. Another question, for the taconite seal, is the horizontal design still default, or is the vertical design default now?
The vertical design, which I showed in the slides, is the standard taconite seal design for SKF, and that is referred to as TK, and then the housing size. And again, I'll refer you to skf.com, where there are data sheets on the available taconite seal range.
Okay, is the drive-up method really practical for small sizes? It just does not justify the cost.
Yep, that's a good question. For small size, you can use the angular tightening method. Up to certain sizes, that's applicable. And again, it's the same for if you had an open bearing. The SKF drive-up method, when you use SKF mount, will give you the same information for the angular drive-up method as well.
Okay. Another question. Can customers use regular sleeve along with sealed spherical roller bearings in case of non-availability of recommended sleeve?
Generally, the sleeve required for sealed spherical roller bearings ends in an E for extended. I would recommend using the recommended sleeve. In terms of using standard sleeves, I'd have to come back with that in terms of a case-by-case evaluation.
Okay. And the last question, would you mind comparing the price of a sealed spherical roller bearing with the open type?
I think fair comment on this one is generally a sealed spherical roller bearing is more expensive than an open bearing due to the additional sealing and grease. But the main consideration when using a sealed spherical roller bearing is what the overall operational costs of that bearing are compared to an open bearing. So as I showed, the reduction in the amount of cost for a maintenance engineer to relubricate it, the cost of the amount of grease you would have to use, and the potential for increasing the service life beyond that of a contamination entering an open bearing, all have to be taken into account when you're doing that comparison. So it's not just a direct comparison of purchasing cost of the bearing on its own. So total cost of ownership is more important than the purchasing price.
Okay. Okay, and those were the questions. Some people would like to thank you for your great presentation. And I would like to thank you as well. I mean, I think it was really clear. And I think all the questions that have been asked are answered by you in a very good way. The last thing I want to say to everyone is that this version has been recorded and it will be shared with you later today or tomorrow. And you will also receive the slide deck with the different contact details for your regional sales managers in UK. Okay, thank you very much again for your time and your attendance to this webinar. Hopefully we will meet you again in one of the next webinars that are still scheduled for the upcoming weeks. Thanks again, Ian, for your presentation, and stay safe and enjoy your day. Thank you very much.